All right, so today we're going to work on addition and subtraction of some mixed numbers. So one of the things that we were working on, we want to make sure we have a common denominator first. So I want to start, I'm going to give you a problem to put in your notebook, and we're going to kind of walk through it together. So I have 2 3/8 minus 1 1/4. I want you guys, before you even solve, if someone could tell me, I already see a problem with this. What do you guys notice?
The denominators aren't the same.
They're not, Aaliyah. So how could I fix my problem? What could I do?
You can times 4 by 2.
And why did you pick 2?
Because when I'm counting by 4s, 2 goes into 8.
Exactly. So Leah looks at this and she's like, I know that 8 is a multiple of 4. I know that 4 times 2 is 8. And then whatever I do to the denominator, I have to do to the numerator too, right? So does this look a little bit better if I was to say, okay, I have 2 3/8 minus 1 2/8? Does that look a little bit better? So if you want, if this is like too much for you, off to the side, you can also rewrite the problem if you'd like. So if you want to rewrite it and put 2 3/8 minus 1 2/8. Some of you look at this and you're like, okay, I know, but others of you might want it to rewrite it and make it a little cleaner. It's kind of up to you. Now, is there anyone that could tell me how I could solve this problem? What do I need to do?
You gotta subtract 3/8 from 2/8.
Yes, and thank you for starting the fractions first. Why did you start in the fractions first?
Because if you started with the big numbers, it wouldn't make the problem look good.
Do you guys remember our lesson from yesterday? I said if you start in the big numbers, you never know. Sometimes you have to borrow, right? So if I said 2 3/8 minus 1 7/8, it wouldn't be possible and I'd have to borrow. So I'd say start in your fractions first, just to make sure in case there is borrowing involved, you might have to go back to that whole number and pull out a whole, pull out 8/8 or whatever you need. So good, start in your fractions first. So 3/8 minus 2/8 equals, anybody? You can just shout out.
1/8. 1 1/8.
Thank you. 1/8. And then with our wholes, we subtract it just like any other subtraction problem. 2 minus 1 is
1.
not so bad, right? Okay, so now I'm going to go to a problem. We're finding a common, it's easy to find a common denominator when they're multiples of each other. So now I'm going to do one where you're going to have to search a little bit harder for a common denominator. So now you're going to have 4 1/5 plus 2 1/3. I want to give you a quick second in your notebook to see if you can solve this on your own, and then we'll talk about it, okay?
Got the answer.
All right, give everyone about 1 more minute.
Okay. Got it.
Good.
I have my answer.
Oh, we're crushing today then, huh?
Got my answer. Got my answer.
All right, sounds like we're good to go. Miss Addie, would you like to share for us this time?
No, because today I'd like some other people to try.
Wow, Addie, I love that you said that actually. Who else wants to give it a try?
Can I try?
Sure. What would you do first?
Wouldn't you subtract 5 and 3? I mean, add.
Well, we can't add fifths and thirds, right? The only way we can add or subtract is if our denominator's the same. So how could we find a common denominator, Bella? What do you think?
Times 5.
Yep, you can multiply them by each other, right?
Yeah.
So in this case, 5 and 3 are both prime. If I had 3 and 9, it'd be really easy. Or if I had 5 and 10, it'd be really easy. But 3 doesn't go into 5. So whenever they don't go into each other, we multiply them by each other. We know that they're fact families. So as Bella was saying, I know 5 times 3 equals 15. And I know that if 5 times 3 equals 15, I know that 3 times 5 will also equal 15. Then we have both of them in 15ths, and that makes it a lot easier. So whatever I do to the bottom, I have to do to the top. So 1 times 3 is 3. And then down here, times 5, I do it to the top. So now it looks a lot prettier. I now have 4 and 3/15 plus 2 and 5/15. Now I can add them because they have the same denominator. Like we said before, like if I try to add fifths and thirds, it's like adding apples and oranges. It just doesn't work together. So you can't add or subtract until you find the common denominator. Now, Bella, do you want to try adding them again?
Yeah. So if you add 5 and 3,
Mhm.
that equals 8.
Good.
So it'd be 8/15.
Beautiful.
4 plus 2 is 6.
Yes, ma'am.
8/15.
Good work. Mr. Ridian, you are our simplification expert. Ridian, can I simplify this any further?
Nope,
Why not?
they don't go into each other.
No, they don't go into each other, and they don't have a common factor, do they? Like I couldn't,
We can only make them smaller, but we can't make them bigger.
I was gonna say we can't, because I can't do 15 divided by 2. I couldn't
We
do,
can't do 8 divided by 3.
no, and 15 divided by 3, nope, so they don't work, do not work. And guys, often you'll see this with odd and even numbers, usually that you
We would
can't,
have to divide by a fraction,
yeah,
which
so it
we
stays
obviously
right
can't
there.
do because we're working with fractions.
Let's try one more. Let's do another subtraction one, and I want to practice one where we might have to borrow. Let's do, okay, here we go. 4 1/3 minus 2 7/15. Make sure you guys find a common denominator before you do anything. Is there anyone, you don't have to solve the whole problem, is there anyone that could just shout out how they found a common denominator? You don't have to do the whole problem, just how did you find a common denominator?
I times 3 by 5 to get 15.
Beautiful. And this one's nice because you don't have to change this guy, right? Our 15ths can stay where they are. 3 times 5 equals 15. Whatever I do to the bottom, I gotta do to the top. Now I have 5/15.
How do I get the 5 though?
So whenever she said she wanted to turn it into 15ths so that it would match this guy, right? And so I had 1/3. So whatever I multiply the bottom by, I multiplied 3 by 5 because I knew it would make 15. I have to do the same thing to the top also. In order to keep it even, you have to multiply the top and the bottom. Otherwise, it's not an equivalent fraction anymore.
I got my answer.
So now I have 1 times 5 equals 5. And 5/15 is equivalent to 1/3. So now, if you want, you guys could leave this how it is. I know for some of you, you like it to be very organized. So what I'm going to do, hopefully you have this in your notebook how it is. What I'm going to do is I'm going to move my 5/15 over. So now you guys can see it lined up on top of each other. So we turned our 1/3 into 5/15. Now I have 4 and 5/15 minus 2 and 7/15. Does anyone see a problem here? No problems?
Oh, I see a problem.
What's the problem?
You can't subtract 7 from 5.
No, if I'm like, hey, Gio, you owe me $7 and you only have $5, what are you gonna do?
I'm gonna try and get more money.
Yeah, you're gonna go borrow some money, right? So we're working in 15ths. So if I take away a whole here, it's just like you're borrowing in addition or subtraction. My 4 becomes a 3. I'm going to take a whole out. And because I'm working in 15ths, 1 whole would be the same as 15/15. Okay. So now Gio has 5/15 plus this whole that he took out, which is 15/15. So now Gio's like, okay, mom hooked me up. I now have 20/15. And now if I'm like, hey, Gio, you owe me $7, he's like, cool, I have $20, no problem. All right, Gio, what would I do now?
Then you would subtract. Oh, wait, no.
You're right. Yeah. We're subtracting.
Yeah, you would subtract 20 from 15.
Well, we're leaving it in 15. So
Oh,
you're
yeah.
right. Our denominator will be 15. But because, remember, guys, if the denominators are the same, you can almost pretend you're just like covering them. Just 20 minus 7 now, which would be 13. Good. And then we took one of our wholes away, right? So now we have 3 minus 2 is
1.
1. Ridian, I'm calling on you for all simplification. Can I simplify, Ridian?
Nope.
Nope. What is 13, guys?
Prime.
Prime. It cannot go any further.
Prime.
Cannot get divided any further. That's it. So we're stuck.
Unless it's by itself or 1.
Yep, exactly. So, and if we divided it by 1, it would still be 13. So that's where we're at. So let's do a couple more together. I want to continue to practice this borrowing because this is really good.
Mom, you said I could take a shower or a bath today.
I'm going to trick you guys. Are you ready?
No.
I am going to give you one where we do not have a fraction on the top. Take a quick second to think. I'll give you a hint. You probably want to pull a hole out of here.
I got my answer.
What? Okay, give everyone 1 second.
Same. Hurry, have it.
I have it too.
Got it.
Addie, I know you said you didn't want to share quite yet. Do you want to share on this one though, Addie?
Yeah, I'll share on this one.
Okay, great.
How I got my answer on this one, since there's 3 wholes and no fractions, and you're supposed to subtract it to 1 whole
Mhm.
and 7/11ths, if you take a whole out of the 3, it'll give you 11/11ths.
Yes, ma'am. How did you know it was 11/11ths?
Because we're subtract the fraction the denominator that we're using is 11.
Yes, ma'am.
And when you subtract 11/11ths
Mhm.
from 7/11ths,
Yep.
you get 4/11ths.
Cool. And what about my whole numbers?
Since there's only 2 wholes left in the top number, when you subtract it by one whole, you get 1 whole.
That's it.
And the answer is 1 and 4/11ths.
Can I make it any smaller?
I'm not very good at simplifying.
That's okay, honey. 11 can't be divided by anything, can it? It's also prime. I can't divide 11 by 2. I can't divide it by 3. I can't divide it by 4. I can't divide it by 5. That's it. So now I'm going to give you guys a brain twister. Are you ready? So we have Dora the elephant. And you guys don't, oh, sorry. Let me scoot this over. You can't quite see it. You don't have to write the actual word problem in your notebook, okay? Dora, she's an elephant, used to eat 2 3/4 tons, because she's an elephant, she eats a lot of food each month. But she got too fat, they put her on a diet. Now she eats 1 7/8 tons of food each month. How much did they decrease her food for her diet? And you don't have to write the whole thing down. So they had to take some food away from her. They're like, Dora girl, you're getting too big. So the first thing I would do is I would circle my numbers if this was on paper, or if I was looking at like a digital test and I was doing it in my notebook, I would circle those numbers and write them down. So in your notebook, you want to make sure you have 2 3/4, and then you also want to make sure you have 1 7/8. So make sure you have your numbers written down, and then we need to come up with some sort of equation. So Dora used to eat 2 3/4 tons of food each month. Now she eats 1 7/8 tons oops, I wrote each month. So what kind of equation could I write for this? Anyone have an idea of an equation? And you might have to use a variable. Hopefully remember back to last year, a variable could be X, it could be A, it could be F, it could be P, it could be any letter really. T for tons maybe. Does anyone have an equation that we could use for this problem?
I have my answer.
Okay, well, hold on. We're going to get to the answer in just a minute. We're going to go through each step. Hey, Aaliyah, how much did she used to eat?
She used to eat 2 3/4.
Okay, so she used to eat 2 3/4, right? And then they're like, Dora, we need to take some food away from you. Do we know how much food they took away right now?
No.
So 2 3/4, I'm going to say minus T for tons. We don't actually know. They took something away. And how much does she eat now?
1 7/8.
So here's our equation. If we follow the word problem, our equation would be she used to eat 2 3/4. Then they said, hey, we're taking some tons of food away. Now she eats 1 7/8. I really want you guys to think about the inverse. Think about the opposite. If I want to solve for this one, I know that this one plus this one, what they took away plus her new total will equal her previous total, right? So how could I solve for this? Addie, how did you do this?
I did it by subtracting the two numbers that we already have.
Cool. So could you tell me what that looks like for you?
So I stacked the two numbers on top of each other.
Okay, I'm gonna do it down on the bottom of my screen. So which number did you put on top?
I put 2 3/4 on top
Okay.
and 1 7/8 on the bottom.
All right. Can I subtract fourths and eighths?
No, you
No.
need to multiply the 2
Huh?
and the 3 by 2.
All right, and if I multiply 2, I get eighths, right?
Yeah, and if you multiply 3 by 2, you get 6.
Beautiful. And again, this is where whenever you multiply the denominator, you have to multiply the numerator too. Ooh, okay. So Addie, now I am left with 2 6/8 minus 1 7/8.
And when you subtract 6/8 minus 7/8, you get 1/8.
Ooh, but if I have $6, can I give someone $7?
You need to carry over one of the 2's.
Mm-hmm. So remember, I was joking with the our fourth graders. I was talking about borrowing and subtraction. And they said if you don't have enough money, you gotta ask your parents, right? So same thing here. If Addie, I say, hey Addie, give me $7 and you only have $6 and you don't have enough, go ask your parents. So then your parents, we take away a whole, right? And how much is that whole worth in this case?
8.
8/8, because we are working in eighths. We give everyone just a sec. Hold on, Addie, 1 second, honey. I want to give everyone just a second to catch up.
Asher knows the answer too.
I know it too.
Asher, do you want to finish the problem for us?
Sure.
Okay.
Okay, so I think everybody's caught up.
Mm-hmm. Go ahead.
Now you have 14/8.
Cool. And that makes it a whole lot easier to subtract, doesn't it?
Yeah, 1 14/8. So
Yep.
you take,
So you did 14/8 minus 7/8.
yep, and then you get 7/8.
That's it. Because my 1 minus 1 is 0, I have no more holes left. And I have
Yep.
7/8. So now, here's the cool thing, is we came up with this equation, right? Let's double check that our work is correct. So we think 7/8 is the answer, right? I'm gonna leave this equation up there and we're gonna check it. We're gonna plug it into our equation. So we're gonna go 2 3/4 minus 7/8. And that should, if we did it correctly, should give us 1 7/8. I'm actually gonna go like this. So I want you guys to test it out. If we are the greatest mathematicians in the world, which I think we are, does it give us 7/8? Whenever you're ready and if anyone wants to explain, will you guys just holler out and walk us through it?
I know that that you at least got a times 2.
Okay, that's a great start. You're right. And why do we have to multiply by 2?
Because if we multiply by any number, any other number, it won't like.
Well, what are we trying to turn it into here?
8.
Yeah, we're trying to turn it into eighths and we have fourths. So if we multiply it by 2, we turn it into eighths. So Amelia, we have a problem. I now have 2 and 6/8 minus 7/8. What's my problem?
You gotta take away a whole from the 2.
Yes, ma'am. So I take it away. And we're working in eighths. So what is 1 whole equal to right now? If I'm working in fourths, it'd be 4 fourths. I'm working in fifths, it'd be 5 fifths. 6 6, 7 sevenths, and 8 eighths.
Okay.
There you go. So now we're back to where we started, actually. Asher reminded us before that 6/8 plus 8/8 is 14/8. So if you have too much on your paper and you want to rewrite it, I'm going to rewrite it a little smaller. It'd be 1 and 14/8 minus 7/8. Because now we've taken away a whole, we've added 8/8 to it to make it bigger. And here's what we're left with. Anyone want to finish it up for us? Ridian, how would I finish it up?
Well, because of why is there a 1?
Why is there a 1? Well, we had 2 holes and now we're down to 1 hole. We're plugging it back into this equation up here to test our answer.
Oh, I actually got confused.
That's okay, no worries.
I got 7/8 as my answer.
7/8, yep, and then 1 minus 0 is 1. So what we were doing here is we were plugging it in to double check. So you guys, if ever you want to use the inverse, if everyone is.
I had 1 and 7/8, so.
That's right.
But yeah, on the bottom number though.
Because we were trying to do 2 and we were trying to test out our theory. We said we thought 2 and 3/4 minus 7/8 would give us 1 and 7/8. And we were correct because that's what we got.
Ah, so I was correct.
Yeah, you're good. Good work. All right. We do have our quiz today. It will be addition and subtraction of mixed numbers. I want to give you, write this in your notebook. Step 1. Find a common denominator. Ooh, I'm running out of room. Find a common denominator. That is the first thing you have to do. Obviously, if they're both ace or they're both 6 or 4, that's fine. But we're not going to see that anymore because that was in 4th grade. Now we're going to finding a common denominator. Step 2. You're going to have to multiply your numerator and your denominator, right? And I'm putting parentheses the same. So I want you guys to sit down and think, okay, fourths and thirds, my common denominator could be 12. Then I need to multiply them to make them the same. Whatever you do to the top, you have to do to the bottom. So if you want to write a little note for yourself, do something like this. Maybe you kind of circle this for yourself so that way you know I have to multiply them to keep them the same. I think that's where some of us were messing up, is we were multiplying to find a common denominator, but we weren't multiplying the numerator also. Got to make sure we multiply both, okay? Give everyone a second to write this down. Will you just holler out when you're done writing, and that way I know I can move on?
Done.
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 So I'm gonna move this up just a little bit. Step 3, once we have found our common denominators and we've multiplied everything to make it friendly, then you're either gonna add or subtract. It kind of, again, depends on your problem, right? And then down here, I might put a star, borrow a whole. Sometimes you're gonna have to borrow a whole, sometimes you won't have to. So I would just leave a little note there, borrow a whole, or you could write borrow a whole if needed. Sometimes you will, sometimes you won't. It really just depends. You hope that your top number is bigger, but in some cases it might not be, right? And then what's our very last step? Once we've added or subtracted, we've borrowed, we've solved it, what do we always check for? Iridian, this is your expertise.
So what am I simplifying?
Yeah, if you can simplify. Step 4 would be check to see if you can simplify. Sometimes you can, sometimes you can't.
There's like 4 11s who can't do that.
No, but if you ended up with something like 8/10,
Well, yeah, but or with something like 24 48.
That would divide down to 1/2. So I'm gonna erase this one and I'm gonna put it back up here. I kind of ran out of room on my board here.
In 24 seconds, I think that's what it is, but yeah, that would head up to a third.
So hopefully on your paper, yours go in order. Step 4 would be on the bottom. Mine's all over the place. Step 4, simplify if you can. I will give you a hint. Give yourself a note. Usually this means dividing it by 2 or dividing it by 3 or dividing it by 5 maybe. 2 will usually work. If it's a multiple of 2, you could divide it by 4, 6, 8, divide it by 3, divide it by 5. It really just depends on what numbers you're working with, right? So if you want to give yourself an example, next to your step 4, you could write something like, I'm just going to give you an example. 1 and 8/12 is going to be my example. I know that 4 goes into 8. I know that 4 goes into 12. If I divide it all by 4, I get 2 thirds. Often you guys will be dividing by 2, 4, 5, 3. You won't be getting anything too crazy, I hope. You're not dividing anything by like 12 or 15, but most of the numbers will stay pretty small. But then some of them, like if you had 7/11ths, it's prime. It can't be simplified. It would just stay how it is. Okay, so just double check your answers. If you notice your answer is kind of big, odds are you can simplify it. And if you notice it has prime numbers, you won't be able to simplify it. We'll keep working on simplifying. That wasn't really like our focus right now. But give it a try as best you can, okay?